ground tow system is a crew-portable, point-fired weapon system used against armored vehicles and hardened fortifications. It consists of a missile, which is referred to as a wooden round, the launch tube, the traversing unit, the missile guidance set, and an optical sight. Operation of the tow system is relatively simple. After the missile is loaded, the operator sights in on the target, launches the missile, and keeps his optical sight trained on the target. An infrared sensor in the sight sees the infrared source on the missile and supplies the position of the missile in relation to the target to the guidance set. The guidance set processes the data and generates steering commands, which are sent to the missile over the trailing wires. The operator needs only to keep his crosshairs centered on the target until impact. The tow missile and launching system do the rest.
The purpose of this tape is to provide an introduction to the Tow Project Office and to serve as an oral history of the early days of tow and allow you to meet and hear from some of the early members of tow and hear from them what it was like in those days. Tow is perhaps the most successful anti-tank missile system, maybe the most successful missile system in the world. We've produced over 500,000 missiles. We've got perhaps 20,000 launch platforms in the hands of over 30 countries. Tow is successful for a number of reasons. It's simple, it's easy to use, it's reliable, it's was designed initially with a considerable design margin so that we've had the flexibility to be able to improve it, and we've chosen to do that. As the threat improved, we've added more warheads, we've added a tougher guidance link, we've added a night sight, and with each improvement to the threat, we've been able to stay just ahead of it. I have no doubt in my mind that our commitment to tow was one of the factors resulting in the changing world situation today that allowed us to be where we are in regard to our relationship with the Soviet Union. The key to all of this is people. People in the Tow Project Office, the soldier in the field, the people at our major contractors, Hughes Aircraft to start with, later on Texas Instruments, the people at Iowa Ammunition Plant and Picatinny Arsenal that have designed the warheads. People who believe in the system, have worked hard to make the system what it is today, are the key to tow. And with that, let's meet some of those people and hear about the tow system.
In 1962, what would eventually become the Tow Project Office opened at MICOM as the Anti-Tank Aircraft Weapons Commodity Office. This small cadre of military and civilian personnel was given the responsibility for bringing along the tow system from its prototype stage to full production and deployment as a viable anti-tank weapons system. Some of the personnel involved in this initial group recall those early days.
And the basic idea, I think, of the tow was that the Army wanted a man-portable command line of sight system. The other systems, like the SS-11, were not command line of sight. The gunner had to track the missile and the target simultaneously. And the the probability of hit was low for the SS-11. And so the question was, could the technology that was available at the time be used to develop a fairly good-sized system that would defeat the main battle tanks at the time and be a command line of sight system?
The idea, the concept at the time was to have this small cadre work with the various elements of the missile command, quality assurance, logistics, engineering, and areas to and monitor them as they develop a weapon system, instead of having a full-blown project office like Pershing had over 240 people. The TOW project initially had about overall 50 people and about 4 or 5 officers, as I remember at the time. And those were the project office to guide the weapon systems into the future.
The organization of the TOW project office has changed somewhat from what it was in those early years, when it consisted of the office of the project manager, configuration office, program management office, and the system engineering, product assurance, procurement and production, and system support divisions. And the job involved one missile, one launch platform, and one customer, the U.S. Army. Today, the project office falls under the Program Executive Officer for Fire Support, with an authorization for 50 civilians and 8 military personnel. Additionally, the configuration, quality assurance, engineering and logistics divisions, although belonging to MICOM, are co-located with the project office and account for another 56 civilian and 5 military personnel. The job now involves a family of 5 missiles, multiple launch platforms, and customers including the U.S. Army, the U.S. Marines, and over 30 international users. While there were less people in those early years to actually perform the physical task, there were also advantages in belonging to a small, dedicated group: teamwork and the absence of red tape.
No, a lot of people, everybody was just working. Everybody would help out each other. It wasn't, well, this is not my job, you know. Everybody just pitched in, and whatever the job was, we just got it done. Ever how many it took to get it finished.
Everybody was working. Anybody had anything to do, they'd bring it to you, do it, and that was it, and then you get it done. Everybody just worked together.
Everybody had a can-do attitude. That's one thing that's always been prevalent in TOW. I've never seen any negativism in TOW. The man said do something, and the team got together and decided how they wanted to do it. And the next thing you know, it was done.
The do something, in the case of the TOW, was to increase the reliability so that it would be a dependable weapon. Together with its industry partner, Hughes Aircraft, the men and women at the TOW project office brought the launch system along, improving its reliability from an early 50% up to 67%, then to 80%, and finally into the high 90s. While the range tests of this experimental system showed promising results, the TOW still had never been fired in combat. This situation changed in the early 1970s.
Missiles with the Vietnam breakers come in at that point in time, where we had to reestablish the UE helicopters with the M-26 launch systems. Those helicopters were brought out of Fort Lewis, Washington, out of Fort Ord, California, and reassembled at Hughes Aircraft Company and shipped overseas. At the same time, missiles that were being produced at Hughes Aircraft Company, instead of being shipped to Anniston Army Depot where they were stored, they were shipped directly over to Vietnam.
In I believe it was in 1972 that we took the system to Vietnam. I'm not sure of that year, but I'm sure of what happened over there. One of the engineers in the project office, he took 3 XM-26 experimental systems on a UHB helicopter to Vietnam, and used the missile those 3 systems over there for about 3 months, and brought back some fabulous film, and showing that the TOW was highly effective even in that jungle environment, standing off and picking off tanks and gasoline storage areas, etc. And it made a big impact there. We also had some ground TOWs over there, and they made a big impact. But
TOW, we would never put a missile in combat. No one had ever put a Army missile in combat. We worked this process, several of us, and we did it in a highly secretive matter. There were secret meetings held a couple of times a day to discuss the process and where we stood. We got news back finally that it had been in Vietnam, it had seen its first combat, and it had been affected by it. I got on a plane and flew to Detroit. Some guy sat down next to me on the plane and struck up a conversation. Where do you work? And I told him. Didn't tell him where to tow, just told him where to Redstone. He said, I understand the tow is tearing them up in Vietnam.
While the tow project office personnel were justifiably proud of the combat performance of the tow system, its effectiveness as a battle weapon had impressed a number of other countries as well.
At the same time, we also had some foreign military sale interest in the tow system. Very minimal at the time, minimal amount of launchers and minimal amount of missiles. But because of the tremendous success that tow had in Vietnam, many foreign military sale countries came in and started asking for missiles, and also started asking for other type of launch platforms, just besides the ground platforms.
Because the tow project office was able to respond to the varying demand, tow is now in the arsenals of over 30 different countries on a variety of land-based platforms. As well as helicopters. Not only did the tow project office respond to requests for various platform configurations, but to requests for increases in range as well. Early in its development, the tow range was increased from 2,000 to 3,000 meters. Now, with the new launch platforms, another request for additional range was made.
The Cobra came along. The Cobra came along after Vietnam was over, and the war games showed that a 3,000-meter missile on the Cobra was not an optimum situation. You would like to have more range for the Cobra to protect it against its enemies. We wound some more wire on the two bobbins that are in the back of the missile. We wound the 3,750 meters of wire on the bobbins. We ran a bunch of tests, and lo and behold, it seemed to work. And all we did was spend the money on the bobbins and development program.
TOW's now been in service for 20 years, since its initial fielding in 1970. And in those 20 years, it has been considered the world's premier anti-tank system. And that's probably because of the product improvements that have been made over those years to keep pace with the evolving threat.
As it had responded to user requests for more range and different launch platforms, the tow project office showed the flexibility of the system by repeatedly adapting it to counter the evolving improvements that were being made in enemy armor. The first step was an improved tow called iTow, which included a larger shaped warhead and an extensible probe to provide more standoff and achieve greater penetration of composite armor. The next step was Tow 2, which incorporated a new probe, a larger, more lethal warhead, a more powerful flight motor, and most importantly, a thermal beacon coupled with a night sight. This beacon and night sight, along with digital electronics retrofitted into the launcher, gave the tow system the capability to operate day and night through battlefield smoke and obscurance. The Tow 2A was developed to increase the system's lethality against vehicles equipped with reactive armor. A tip charge at the end of the extensible probe detonates the reactive armor, exposing the primary armor as the main warhead detonates. The TOW-2B is designed to fly over a target, avoiding the heavily armored sides of the vehicle, and detonate its dual warheads down onto the more vulnerable top surface of the target. Early tests of the TOW-2B system are very promising.
So one of the reasons that TOW is still around is because the project managers recognize the versatility of the system. It started out as a man-portable, 3 men supposed to be able to carry it. It adapted then to the Jeep and the 113 and the improved tow vehicle and the Cobra and the Bradley and some of the other systems that started back in that same era, i.e. Shillelagh and SF-10, 11, and some of those things, are no longer around. They didn't make the adaptation to the new vehicles, the new platforms, the increases in range, the changes in threat that the TOW was able to make. And that's why TOW is still here and why it'll be here in the future.
TOW Project Office is now about to embark in the most significant product improvement since the initial development of TOW. And that product improvement is oriented at modifying the system to upgrade the fire control and target acquisition systems. The TOW Site Improvement Program will utilize the latest and advanced technologies in those areas to upgrade the system. And what we're looking at trying to do is go to second-generation flare technology so that our gunners can see further in all environments and use advanced microprocessing techniques so that we can perform with the system such things as auto-tracking, multi-launching, embedded training, improving our built-in test capability. And with those kind of improvements, we will have upgraded the TOW so that it is now current and will be current for many years to come.
Through the multitude of changes TOW has seen, the team effort, can-do attitude, and the desire to give the soldier in the field the best possible anti-tank weapon, so prevalent in the early days, have remained consistent and have been the key elements in TOW's success through the years.